Okay, going to get through this quickly because I'm about to teach. So this is a question I think is really interesting. It's on the AS stats on the integral maths, and it's B1 and it's question 6, which I think is really good. What is the least number of times you need to toss a fair coin so that the probability of having at least one tail is greater than 0.9999? Right, so what's the least number of times you need to toss a coin so the probability of getting at least one tail? There's a lot of language there. So let x be the number of tails you get. Okay, and so I know it's a binomial distribution because you get heads or tails, don't you? I don't know n because that's what I'm looking for. But also it's a fair coin, sorry. So P is 0.5. And they're saying, what's the probability that I get at least one tail? So x is greater than or equal to 1. Has to be greater than point, and then how many of these? I think there are 4 of these, yeah. 1, 2, 3, 4. Now, of course, cumulative frequency, we're going to go the other way. And we're going to say that is the same as 1 minus the probability that x is 0. Boom. And that, if I swap all that around, you should see that that means this. 1 minus that. I think, yep, there. So now, the probability of getting none, we know is 0.5 to the n is less than. And now we're into our logs, aren't we? And doing it that way, which is really nice. So I'm going to lose the ln on this one because I like ln. So I'm going to ln both sides. And then I've just got to remind myself, because sometimes I'm a bit silly, forgetful. So ln 0.5 is a negative. Now why is that important? Because when I'm going to divide by a negative, the sign changes. So that changes now. Okay, so that's a key element, a thing that a lot of people do get wrong. So let's try that now. It's going to be natural log 0.001 divided by, oh dear, don't do that. Put a bracket and then divided by, we'll just do it nice and slow, don't rush. Yes, I know, I'm coming. And there you go, 9.96 or 9.97. So that is probability there, which is not right. That should have worked. Why didn't that work? Why didn't that work? Why not work? Oh, silly Billy. Look at that. It's another 0 in there. See how simple errors you can make. Oh, there you go. 13.29. So just check all your workings out. So n has to be greater than 13.9. So therefore it has to be at least n has to be at least 14. Whew. Again, a lesson in not rushing. More speed, less haste. More haste, less speed. I don't know which it is, but that's how you'd answer that one.